Welcome to aminacademy.com. In organic chemistry, let us discuss about mechanism of organic reactions. Having looked at the kinds of reaction that takes place, let's now see how reactions occurs in organic products. An overall description of how a reaction occurs is called the reaction mechanism. Reaction mechanism describes in detail exactly what takes place at each stage of chemical transformation, which bonds are broken and in what order, which bonds are formed and in what order, and what the relative rates are for each steps. A complete mechanism must also account for all reactants used and all products formed. All chemical reactions involve bond breaking and bond making. Then two molecules come together, react and yield products. Specific bonds in the reactant molecules are broken and specific bonds in the product molecules are formed. Fundamentally, there are two ways in which a covalent two electron bonds can break. A bond can break in an electronically symmetrical way so that one electron remains with each product fragments, or a bond can break in an electronically unsymmetrical ways so that both bonding electrons remain with one product fragments, leaving the other with a vacant orbital. The symmetrical cleavage is to be homolytic and the unsymmetrical cleavage is said to be heterolytic. Now let's develop this point in more detail. Some more detail now. Here there are six main types of reaction mechanism in organic chemistry. These includes substitution, addition, elimination, rearrangements, radical and redox reactions. What is meant by reaction mechanism in organic chemistry? A reaction mechanism shows how electrons move and bonds from and breaking in a reaction. A reaction will show reactant and products. The mechanism will include all intermediate and how those intermediate were formed. Now, a radical substitution reaction is a reaction which occurs by a free radical mechanisms and results in the substitution of one or more of the atoms and group present in the substrate by different atoms or groups. The initiation step in a radical chain reaction is the step in which the free radical is first produced. Here, look at this initiation. Here, the bond, here A to B, the bond, the heat or light is given, that bond is separated. Like here, A and B is separated. Propagation is, look at A dot plus C bond D. Here, A is bonded with C and plus D is separated. That is called a propagation. And one more example, then D and the continuation D plus E bond F gives D is bonded with E and F separated, etc. It goes. Now termination is F dot plus G dot gives F bond G. Here further we'll discuss. A radical reactions are not a common or polar reaction but are nevertheless important in some industrial process and biological pathways. Let's see briefly how they occur. A radical is highly reactive because it contains an atom with an odd number of electrons, usually 7, in its valence shell, rather than a suitable noble gas octet. A radical can achieve a valence shell octet in several ways. For example, a radical might abstract an atom and one bonding electrons from another reactant, leaving behind a new radical. the net result is a radical substitution reaction. These are radical substitution reactions. Now, what is initiation? Like many radical reactions in the laboratory, methane chlorination requires three kinds of steps, that is initiation, propagation and termination. We'll discuss it. Initiation is irradiation with ultraviolet light begins the reaction by breaking the relatively weak chlorine-chlorine bond of a small number of Cl2 molecules to give a few reactive chlorine radicals. Yeah, look at this initiation law. We'll discuss one more time, like here, suppose here, chlorine, some bonds here. Give light, use two chlorine bonds. Next is propagation. Propagation, once produced, a reactive chlorine radical collide with a methane molecule in a propagation state, abstracting hydrogen atoms to give HCl. For example, here, that is chlorine, two dots here, one dot, plus H, two dots with CH3, like here. Next is termination. Termination, occasionally two radicals might collide and combine to form a stable product. When that happens, the reaction cycle is broken and the chain is ended. Such mechanism steps occurs infrequently. However, because the concentration of radicals in the reaction at any given moment is very small. Here, this chlorine, here that it becomes like it's continuous. So far we discussed about somewhat about mechanism of organic reactions. We will discuss in detail in future videos. We have done. Please subscribe our YouTube channel.